Hello viewers, how are you all? I think all of you are fine at home. So today I am continuing the mathematics 9th class number system exercises and example questions of NCERT textbook part number 2. If you have not watched part number 1, please watch it. Okay. Let me move to the slides. In the last video, we have solved up to third question in exercise 1.3. So we are continuing the fourth question. So our fourth question is here like this: express 0.999 bar in PYQ form. Are you surprised by answer? Before that, let me solve this question. So let me solve this question first. So I have told in the last video what we should do. X is equals to 0.999 bar. Okay, this is a question given by the textbook, means a question by the textbook organizer. Okay, what we should do here, multiply 10 to both the hand side, like LHS and RHS. We will get 10x is equals to 9.9 bar. Okay, we will get 9.9 bar, so on. So what we should do, 10x as it is we should write, and then 9 plus 0.99, we can split the 9.9999 as 0.999 plus 9, we can divide it. Okay, I will continue the steps here, and then this 10x is as it is, and then this 9 plus x we can write, because here we have put x as 0.9 bar, and this both are the same. Then 10x minus x is equals to 9. 10x is then 9x is equals to 9. Then x is equals to 9 by 9. 9 will get cancelled, and x we got 1. Yes, we got the answer 1. How? Are you surprised by your answer? Yes, I am surprised because the question is 0.999 bar. Whenever we express this, the answer will come in whole number. Oh God! With your teacher and classmate, discuss why the answer makes a sense. Yes, it came 1 because whenever we write 0.9999, whenever we estimate this, we will get 1 only. Whenever we estimate this, we will get 1 as our answer. So our answer got surprise. Our answer makes us surprise. Okay. Next question: what is the maximum number of digits? Be repeating in block of digits in decimal expansion of 1 by 17. Perform the division to check your answer. So 1 by 17, we will get our answer as 0.058823529 529 4117 4117 647 bar. So our answer is this much big. So if I go on doing the long division of this 1 by 17, it may take 15 to 20 minutes. Okay, because it is very long. So I am giving this as a homework. The answer will come exactly this much only. The answer is this much only. But to do it at your home and check your answer by performing the long division method. Okay. Next, moving to our sixth question. Look at several examples of rational number in the form p by q, where q is not equals to 0, and where p and q are integers with no common factors other than 1 and having terminating decimal representations or expansions. Can you guess what property q must satisfy? So there is one property. What is that property? A decimal is terminating if the q. So p by q, they have given the rational number is in the form of p by q, where the p and q are integers and q should not be equals to 0. A decimal is terminating. A decimal is terminating if x is in the form of 2 raised to m and 5 raised to n. So this is the important thing you should remember. Okay, this 2 raised to m and 5 raised to n, if the number is in this form like a 2 raised to n and 5 raised, sorry, 2 raised to m and 5 raised to n, that then that number is terminating. So let me take some examples. Let me take some. What you should write in this, I will tell you. You should write, take down this. A decimal is terminating if the q is in the form of 2 raised to m and 5 raised to n. This you should write the answer. And let me take some examples. Okay, the examples are here for you. 1 by 2, 1 by 2 is our question. So 1 by 2, what we should do, we should multiply 5 by 5 to it. We will get 5 by 10. We will get 5 by 10. So its decimal expansion is 0 by 5. 0 by 5 is nothing but, sorry, 5 by 10 is nothing but 1 by 2 raised to 1 and 5 raised to 0. Okay, 2 raised to 1 and 5 raised to 0. Another one example I will give you. 4 by 25. 4 by 25. We should multiply 4 by 4 to it to make the denominator or make the q 2m into 5 raised to n. We should make the denominator 2m into 5 raised to n, then we will get the answer as terminating. So here we will get 16 by 100, 16 by 100. So here q is in the form of 2 by m and 5 by n. Okay, I think you understood this point. If you have not understood, you can watch the video once. Moving to next, write 3 numbers whose decimal expansion are non-terminating and non-recurring. You can write any. You can write any 3 decimal expansions. Let me give you some expansions here. First one, 0.01. What they ask, non-terminating, no? 0.001, 0.000, 2, 3, 5, 6, 7, etc. Another one, let us take another one. 0.16356, so on. We can take third one. We can take 1.6356665, so on. We can take, you can write any examples. Okay, moving to next. Find 3 different irrational numbers between rational numbers 5 by 7 and 9 by 11. Okay, you have got some problems in last video. Okay, there the denominators were same, but here the denominators are different. How to solve this? So you should make the denominators the same again. What we should do here, they have asked 3 different and different irrational numbers we want. What we should do here, we should find what is 5 by 7. What is 5 by 7? That is 0.714285. 714285 bar is the decimal expansion of 5 by 7. And then let me erase this and write this below here. Let me erase all this. Okay. Then decimal expansion of 9 by 11. 9 by 11 क्या होता है? 0.81 bar. Okay, you can write any irrational number between 0.714285 and 0.81 bar. So I will give you some examples here. 0.726 bar you can write. Then 0.790701 dash you can write. You can write another one example, that is 0.78 7 8 dash 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 dash. You can write these are the three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So moving to the ninth question, that is classify the following numbers as rational and irrational numbers. Classifying the following numbers as irrational and rational. So you can write this. I will also give you root 23. Root 23 is irrational number. Irrational. Why it is irrational? Because we cannot expand or represent root 23 as rational number. Then root 25 is rational number. Why? Because so root 225. Its answer we will get 15. Then it will be 15 is a whole number. Then all whole numbers are rational numbers. Then it is a rational number. 0.3796, it is also a rational number because it is terminating. This is irrational number. This is irrational number. Why? Because it is repeating. It is repeat. Sorry. It is not irrational. It is rational. Sorry, it is not irrational. It is rational. Why? Because they are non-terminating and repeating. Non-terminating and repeating will come under rational numbers only. Then 1.0, sorry, see that question, 1.101001000010001, then it will continue. So here nothing is terminating, it is not terminating, and no pattern is recurring. So this is irrational number. This is irrational number. First one is irrational. First one is irrational. Second one is rational. Third one is also rational. Fourth one is also rational. Fifth one is irrational. So first and fifth are only irrational numbers from the given questions. I think you understood the reasons also. Okay, so let us solve the uh, solved examples of this chapter, means exercise 1.44 examples, solved examples. Visualize the representation of a 5.37 bar on the number line up to 5 decimal points. 5 decimal points is nothing but they have already given, they are 3 7 7 7 7. We should represent this on the number line. How to represent this? So first make the number line. Then what we should represent here? Let us represent 0 1 2 3 4 5 and 6. So 5.37777 will come between 5 and 6. Let us magnify this. Again draw a number line and put 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, 6.0. This is a magnification of 5 and 6. So again 5.3777 will come between 5.3 and 5.4. Let me take the another screen to explain you. Okay, what we should do here, 5.37777 we should represent on the number line. We have already represented 5.3 we have already represented 5.126 we have already represented. Okay, then what we should do here, we should expand 5.3 and 5.4. How to do this? Again draw a straight line which should contain two uh, arrow marks, and then let us write 5.31 5.32, 5.33, 5.44, 5.44, 5.55, 5.56, 5.57, 5.58, 5.59, 5.60. Oh, sorry, I have made a mistake. Wait. Sorry. Let me erase this. This is wrong. This is wrong. Let me erase this and let me take pen here. Okay. 5.34, 5.35, 5.36, 5.37, 5.38, 5.39, 5.4. So 5.3777 will come again under 5.37, 5.38. Please concentrate here, then you can get it correct. So how can we expand this? 5.371, 5.372, 5.373, 5.374, 5.375, 5.376, 5.377, 5.378, then 5.379 and 5.38. Okay, again this will come between 3.777 and 3.778. Oh my god, how much big it is. It is very easy, but it is lengthy. Okay, 5.3771, 5.3772, 5.3773, 5.3774, 5.3775, 5.3776, 5.3777, 5.3778, 5.3779, oh my god, 378. Oh my god, how much big it is. So again we want another one decimal point, that is 5.37, that will come under 5.377. Okay, that is 5.37771, 5.37772. Oh my god, 5.37773, 5.37774, 5.37775, 5.37776, 5 point, wait, 5.37777, 5.37778, 5.3779, 5.3778. So finally we got our answer 5.3777 here. Let me make this point as B. Okay, this was the representation of rational number sorry, irrational number, so rational number only, 5.3777 on the number line. I think you understood this. If any question comes like this, you should do it as a homework because it needs many more time to solve. So moving to exercise 1.4, that is 3.765. So I will solve this one and I will give you the homework. Second one, okay, second one is the homework, okay, because that is also long again. What we should represent, okay, I don't want this page, let me take the five. Remember this question, what is that? 3.765, representing 3.765 on the number line. What we should do first? 0, 1, 2, 3, 4, 5, 6, 7, 8. You can take up to 10 also, okay. So 3.765 will come under 3 and 4. 3 and 4. Let me expand it. 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and 4.0. We got 4.0. Then 3.765 will come under 3.7 and 3.8. Let me expand this, let me magnify this. Then we will get 3.71, 3.72, 3.73, 3.74, 3.75, 3.76, 3.77, 3.78, 3.79, 3.8. So if I have made any minor mistakes, please don't mind it, okay. 3.765 will come between 3.76 and 3.77. This is our last step of this question. 3.761, 3.762, 3.763, 3.764, 3.765. We got our answer. 3.766, 3.777. Then where is 3.7, sorry, 767, 768, 3.769, 769, 3.770. Finally we got our answer. Here is our answer. Let me make this point as P, and P is equals to 3.765. Okay. Okay. This question was solved. So second question, 4.2626 on the number line. You should do it as your homework. This one I am giving you as a homework. This is very easy to do for you, but it is very tough to do for me because I am doing the questions, solving the answers with mouse. Okay. So here, wait. Yeah. Okay. So our theory part of 1.5 is here. Check whether 7 root 5, 7 by root 5, root 2 plus 21, pi by 2 are rational numbers or not. We should check this. So what we should do first, 7 root 5 is a irrational number. I will tell you something. The the product of rational and irrational number is always an irrational number. The product of rational and irrational number is always an irrational number. Here 7 is a rational number, root 5 is a irrational number, then this is a irrational number. 7 root 5, 7 by root 5, again same. If the answer. The quotient of rational and irrational number is also an irrational number. Here, this is also an irrational number. This is also irrational. This is also an irrational number. Then root 2 plus 21. The sum of irrational number and a rational number is always an irrational number. Then here this is also an irrational number. Then pi minus 2. The answer, whenever we subtract a rational number and irrational number, our answer is again irrational number. Pi is an irrational number, so all the given answers are irrational number. All the given answers are irrational, questions are irrational number. These four are irrational number. I have said reason also. Okay, I have said reason also. So 13th example, add 2 root 2 plus 5 root 3 plus 2 minus 3 root, oh sorry. So what we should do here, we should add 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. We should add this. Then what we should do here is, here you can observe the answer, 2 root 2 plus 5 root 3 plus 2, plus root 2 minus 3 root 2. So here the next step is, next step we will get is 2 root 2 plus root 2 plus 5 root 3 minus 3 root 3. How? Because how this root 2 is multiplied to both these numbers, and this root minus 3 root 3 is also multiplied to both the numbers, and we will get 2 root 2 plus root 2 plus 5 root 3 minus 3 root 3. So we will get 2 plus 1 root 2, because root 2 is common here and here nothing is there, means here we will have 1. Okay, 2 plus 1 root 2 plus here 5 minus 3 and root 3 is common, root 3 we can take, then 2 plus 1 is 3 and 3 minus 2, 5 minus 3 is 2. So we got 3 root 2 plus 2 root 3. I think you understood this. So moving to next question. So I think you understood this answer. So let me move to 14th question. We should multiply 6 root 5 and 2 root 5. What we should do? We should first write the question as it is. So yes. Then we should multiply the numericals first. Then 6 to the 12 and root as it is. Root 5 into root 10 is root 5 is equals to root 2 is equals to root 10. So our answer is 12 root 10. This much, very much easy this answer is. Okay. Next question we will solve here. 15th question. Divide 8 root 15 by 2 root 3. 8 root 15 by 2 root 3. 2 ones are 2 fours are. 4 we got root 3. This root will get cancelled. 3 ones are 3 fives are. 3 ones are 3 fives are. Let me solve that again for you. So 8 root 15 by 2 root 3. This root will not cancel. I have clarified that. So root 1 and root 2 ones are 2 fours are, we will get 4, and then this root will be as it is. Root will not cancel. 3 ones are 3 fives are. 4 root 5 is our answer. So I have made a mistake in the last step. So I clear that and I solve this once again for you. So let me erase this and move to the 16th question. That is, simplify the following expressions. I think you can simplify this. Then only, then also I will give you the answers. 5, 2. 5 2s are 10 we will get. Then 5 is multiplied to root 5 also. That will be as it is. 5 root 5. Root 7 into 2, we will get root 7 into 2. What we will get? Root 7 and root 7 and 2. We will get the answer as, that is 2 root 7. Then root 7 and root 5, we will get root 35. Nothing we can cancel here. Okay, we cannot cancel anything. So the answer is as it is. Second one, 5 root 5 means this 5 will multiply to these both, and then we will get 5 5 is 25 minus 5 root 5 plus 5 root 5 plus 5 root 5 minus root 25 minus root 25. So we can simplify again this 25 as it is, 25 as it is. This both will get cancelled, and the root 25 is nothing but 5. Then we got our answer as 20. Our third question is root 3. What is root 3 root 7 whole square? Which identity is important here? That is a plus b square. You have learned in class 8 this a plus b whole square. What will be our answer? A square plus b square plus 2ab. Okay, this is a, this is b. Then a square plus root 7 whole square plus 2 root 3 root 7. Root 3 and root 7. So this square root and square will get cancelled, 3. This both will get cancelled again, 7 plus 2. We can multiply this, then our answer is root 21. So our answer, final answer is 10 plus 2 root 21. This is our answer. Moving to the next question. Let me erase this. Wait for a while. Yeah. Fourth question. This implies a minus b, a minus b, a plus b. You have learned this. What is the answer? Can you guess the answer? Yes, the answer is a square plus b square. This identity also I have learned in class 8, that root 11 is what? Root 11 is our a, and minus or only root 7 is our b. Then very easy to get the answer. Root 7 whole square minus root 7 whole square. Root 11 whole square minus root 7 whole square. This both will get cancelled, and 11 again in the same case. Our answer is 4. We got our answer as 4. This was very easy. So moving to 7. What is rationalizing? Rationalizing is nothing but rationalizing is very easy. Rationalizing is very easy. If we multiply one irrational number to another irrational number, I am telling the definition of rationalization. If we multiply one irrational number to another irrational number to obtain a rational number, this process is called as rationalization. Then the second irrational number is rationalization factor of first irrational number. So what we should do, a irrational number is multiplied to another irrational number to get a rational number. So that both irrational number we multiplied will be the rationalizing factors to each other. This is very much easy. 1 by root 2. 1 by root 2. We should multiply root 2 to both the sides. Root 2 to both the numerators and denominators. Then we will get root 2 by root 4. Our answer is root 2 by 2. So root 2 by 2 is rationalized form of 1 by root 2. I think you understood. This is very easy. Moving to 18. This will be given you here itself. I thought it should be given to a homework, but it is little difficult compared to that. So what we should do here, Very easy. If we want rationalizing factor, one trick I want to tell you here is we should change the sign during the changing. Okay, here what we should do, we should, here we are having plus, we should take it minus and do this step. 2 minus root 3. What we will get? We will get 2 minus root 3. What is the answer of 2 plus root 3 into 2 minus root 3? What will be our answer? Our answer will be, let me multiply here. 2 to the 4. Then 2, due to the problem in PowerPoint that slide gone, so I'm explaining you this through the textbook itself. So rationalizing 1 by root 1 by 2 plus root 3. So what we here they have given explanation. We use the identity 4 given earlier, multiply and divide 1 by 2 root 3 by both the numbers. What we will get here? So 1, sorry. So as I told, we should multiply the rationalizing factor of the denominator, to numerator and denominator. So we have made a multiplication. The step is same, and then we will get the answer 4 minus 3 whenever we do the sum. 2 plus root 3 and 2 minus root 3. So we will get 2 minus root 3. Why? Because 4 minus 3 is equals to 1. 4 minus 3 is equals to 1, then 2 minus the root 3 will be our answer. Moving to our 19th example, rationalize the denominator 5 by root 3 minus root 5. What we should do here is nothing but multiply root 3 plus root 5 to both numerator and denominator as shown in this example, or as shown here, and then we will get 5 root 3 plus root 5, then we will get root 15 plus root 25, then that answer will be minus 5. Sorry, that answer will be only 5, but this minus 2, 3 minus 5 will get, this minus 2 will take the denominator, sorry, numerator take the minus because of its denominator. So our answer, sorry, not our answer, our answer is here minus 5 by 2 bracket root 3 plus root 5. I think you understood this. If you have not understood, you can replay this video. Okay, again our 20th question is 1 by 7 plus 3 root 2. We should multiply 7 minus 3 root 2 to both numerator and denominator to obtain a rational number. So what we should do here, this number will be as it is because it is multiplied with 1. Then whenever we simplify 7 plus 3 root 2 and 7 minus 3 root 2, we will get 49 minus 18. Then 7 minus 3 root 2, whenever we subtract 49 and 18, we will get 31. Then our answer is 7 minus 3 root 2 by 31. This was our answer. So due to some technical problems, the slides cannot be watched. So from continued, you can watch the slides. Moving to exercise 1.5, classify the following numbers as rational or irrational. So this is irrational because, as I told, the sum, the difference, the product and the quotient of rational and irrational number is always an irrational number. First one is irrational number. First one. Okay. Second, let me see the question. 3 plus root 23 by minus root 23. This is rational number. Why? Because we can cancel these both and we will get our answer as 3. Then 3 is a rational number, no? 3 is a rational number. Let me erase this. Wait for a while. Let me erase this and move to the third question. Third question. 2 root 7 divided by 7 root 7. This is again rational number. Why? Because we can cancel these both. Then third one is also a rational number. Let me erase this. Okay. So 1 by root 2, it is an irrational number because the the quotient of the rational and irrational number will be irrational number. Fourth one is irrational number. Fifth one, 2 pi. The product of one rational and one irrational number is always an irrational number because pi is an irrational number. Fifth one is also irrational number. First, fourth, fifth are irrational. Second and third are rational numbers. Moving to the second. Simplify each of the following. These will be your homework. You should solve this because I have I have shown the textbook how they solved, and I already explained that using the identities you should solve this second main. Okay. So, third, it is little lengthy question. That is, pi is defined as the pi is defined as the ratio of the circumference. Circumference is said as c of a circle to its diameter, say d. Circumference is c and diameter is d. That is, pi is equals to c by d. This seems to contradict the fact that pi is irrational. How will you resolve this contradiction? So what I will write the steps here. There is no contradiction either C or D. Write this point. There is no contradiction either C or D is irrational number and hence pi is irrational. So there should be no condition. There should be no condition to C by D is irrational, then pi should be also irrational. Okay, I think you understood this. Moving to fourth question. Represent root 9.3 on number line. Okay, let me solve this. What we should do, first take the line like this. Name it as, I will solve only with this problem. You are having again the, sorry, wait for a minute, I'm just checking the textbook. Again we are having, no, this is the last problem. Yes, this is only one problem for you. So what we should do, first take a line AB, line segment, not line segment AB of 9.3 centimeter, 9.3 centimeter. Then after this, what you should do, take a point C after B of any unit. You can take of any unit. Then draw and then make the perpendicular bisector of AC. Perpendicular bisector of AC. Perpendicular bisector of AC. This is not perfectly. Just I am telling you to make the perpendicular bisector of AC and make the semicircle AC using the, make the M as midpoint and taking AM as the radius, draw a semicircle. After that, make a perpendicular line to the semicircle. Perpendicular line to the semicircle by taking B as the point, and then this is D. Taking BD as radius, cut an arc. That will be our 9.3. That will be our 9.3. Let me solve this again. First, take a line. Let that should be, sorry, take a line segment that should be of 9.3 centimeter. 9.3 centimeter. After that, what you should do? After that, take this point C. Take point C after B. That should be of at least 1 to 2 centimeter. You can take it how much you want, but that should be little. Okay. Then draw a perpendicular bisector of AC. I am telling you, draw a perpendicular bisector of AC and make this midpoint as M and taking AM as radius, draw a semicircle of AC. After that, draw a perpendicular to B. Draw perpendicular to line B and name it as BD. Taking the radius BD, cut an arc on the line that is E. Then our E is root 9.3. I think you understood. I have solved this 2 times. If you have not understood, you can watch the video again. Okay, fifth question. Rationalize the denominators. Very much easy. Wait, let me solve this and you will only understand. Yes. Root 7 by 7 is the rationalization factor, and these three are your homework. I have solved many problems. I have solved all the solved examples, so you should solve. If everything is done by me, then what will you do? Okay. If you have not understood, then you can put on comment box. Then I will solve this in my next video. Okay. Then simplify first one. I think the time is over. We can solve these questions in our next part. Let me meet in that part. Till then, take care of yourself and bye bye. We have just left 1.6 exercise and solved theory part of 1.6 exercise. We can complete this in part 3. Let me meet in part 3. Till then, take care of yourself. Bye bye.